Welcome everyone to the talk about ORMs and NORM from Henrietta. Henrietta has a PhD in computer science. She's been a long-time member of the Postgres community. My introduction to Henrietta was about 2 years ago. She wrote her first book. I happened to have a connection at the publisher, and he knew I was doing Postgres stuff. He said, hey, we'd like to see this book. I was like, great. So I got to meet her last year. It's been a pleasure. She's a great community supporter, and she's going to be the host of the next conference in Chicago, which is going to be awesome. So really a great contributor, and you can learn a ton by everything she gives out to the community. So she'll introduce more of herself. But
yeah, great. Thank you, Rand. So hello. Okay, after lunch, okay, somebody survived. Thank you. My name is Hetty, and Postgres community knows me as Hetty. You do not need to know the rest. There is only one Hetty in Postgres. You can Google Postgres plus Hetty. You will learn more than you want to know, more than I want to know probably, but yeah. My GitHub is Hetty-D, so also very easy, and there will be GitHub links here. I've been doing databases here for super long time, and the last 11 years exclusively Postgres. This talk, I just did this talk twice last week on 2 different conferences, and now I'm doing for the 3rd time. So funny story, in December 2021, here in New York, on first PGConf New York after pandemic, so there were 2 things. First of all, I came like, hey, guess what? I have a new job. I just joined EDB. And also, that's the last time I am giving NORM talk. I know everybody loves it, but I promise that's the last time. So now in September 2022, hey, I got a new job, actually. I'm sorry. I'm not a millennial, I promise, but I work now for DRW. It's a trading firm in Chicago. Totally love them. And I'm giving NORM talk again. So I promise it's different talk. In some sense, I feel like for all my professional career, I'm doing like one talk all the time because I always talk about application and databases and how they are connected. And for some reason, it's nobody's topic. Nobody likes it. Nobody wants it. It was very difficult for me for the longest time to get on any conferences because it's not application, not database, and God knows what. This Hetty's thing, it was this Hetty's thing for a very long time. So finally, it got a name. Now it's called NORM, and it's not this JSON thingy that Hetty is doing. So I'm at least very happy about that. So this version 2 was done in collaboration with Boris, who was going to be here, but he actually had 1 more week of conferences prior to our last week's conferences, so kind of it was too much. So I will talk just solo today, but I just wanted to mention that his contribution was like absolutely essential because he wrote most of the code for NormGen, so this new iteration of NORM. And I was just criticizing why this thing works. It does not look pretty or whatever, what in the world are these IDs. And I did like testing. So if something, I would ask everybody actually to go give it a try, but if something does not work, blame Boris. For a change, you do not need to blame Magnus, blame Boris. But honestly, his contribution is like super essential here. So as I said, are we like moving? Yes. Okay. So I just joined DRW, so I was a little bit panicking because new company is always new template, but they actually were very gracious, said, Hetty, you developed it without us, before us, so you do not need to do it company template. You use whatever. So it's like one of the few chances in my life when I can use our personal template. And it's like HDBN, it's like me and Boris, HDB, so DB, it's like DB, and so our initials make it AD. And 2 tigers are because we are both tigers by the Chinese horoscope. So, all right. So since most database people, not developers, will have a quick quiz, and I mean you know this, but just do refresher. So it's ORM in the title of this talk. So what is ORM? ORM, what is ORM? Object-Relational Mapper, thank you. Okay, so why developers use ORM? Actually, there was a talk right before me, before lunch here, and they were also trying to say, so why application developers use ORM while it is? All right. You're probably right, but we have like politically correct statement to abstract from database specific. That's like another polite way of saying this, because yes, they do not know, they do not want to learn SQL. So they want to abstract from database specifics. So next question, why NORM is bad, scratch, good? So what I mean good, they are using it, okay? So in spite of we are unhappy, they're still using it. So why the application developers think ORM is good? Any ideas? Right?
It supposedly addresses the object-relational impedance mismatch.
It does not actually. It creates it. So why it is? Again, there were talks about this actually. Just the previous talk was a little bit about that, because you know what is everything. So the application developers' time is valuable. Okay, so we need rapid development, because we want to MVP, and then this MVP becomes an actual product. So that's why they're using it, because it's fast. Develop fast without knowing anything about databases. So now, for real, why it is bad? Why it is bad? What? ORM is a mapper. What is slow about ORM? It creates a bottleneck. Again, there is a polite term. It's like inefficient data access patterns. That's like the word for what ORM is doing. Okay. So now, okay. So we have applicational model and we have database model. Application model is object-oriented. So that's where database model is object-relational if we're talking about Postgres. So both are complex models. Both models have complex objects because world consists of complex objects. There's nothing simple in the real world. And application databases, they reflect the real world. And how they communicate. They do not know how to communicate. That's how they communicate. They communicate in this like little tinsy, wincy, small elements of data. ORM is right here. So what ORM does, it abstracts. So how it abstracts, it disassembles this complex object on the application side, because there are like methods. It maps each attribute individually. Then these attributes are sent through JDBC in case of this Java application. And then on the database side, they are not put together because there is no way to put together. So instead of sending a query to database, application sends these little queries, and then they're executed on the database, and each result is sent back. And also, it's not simultaneous. You need to send this tinsy query, receive result, send another query, receive result. So all this, that's where the real cause of slowness, because it's like, it cannot. So that is our bottleneck. All right. So, and the result is, well, wait. Like we all know that, okay, we press OK, see this, like please wait. And during this time, you know how many queries go? Nothing should happen, you know, because we already told the application what to do. We do not input any extra information. It may be several hundred up to 1,000 database calls until we see something as a result, okay? So why it is bad? So, okay, all right, it's annoying, but why actually waiting is bad? And why is bad? Why, except for being annoyed.
Why? Good performance in your application.
Yeah, why we need good performance? Like, what happens? Yeah, okay, so just repeat, I'm from Chicago, okay? So, from trading firm before in many financial organizations, all about money. It's all about money, okay? That's why waiting is bad. Waiting is bad has very mandatory like explanation. Amazon data. 1/10 of second increase response time, 1% of sales loss. And 1% of Amazon sales loss is goddamn serious. More, 50% of visitors abandon the site which is not loaded within 3 seconds. And during my lifetime, this is decreasing. I remember it was 11 seconds, then 7 seconds, then 6, then 3, and I think actually now it's 1.5 seconds. And what is worse, they do not come back. First time they experience slowness, they do not come back. So that's why we do not want things to be slow. Okay? What application developers say, because they also do not like this. So now they say, we need to scale. You know how I hate it? People ask, what you do with scalability, how you scale. And so what do you mean scale? What do you mean scale? Okay. So like as I said, I just wrapped up my tenure in EDB, so I talk to customers. You know what we tell customers? So, okay, so we need more hardware. So almost all data should be in main memory in order for Postgres to function. So almost all data, that's like how much? With current database sizes, I mean, I saw machines with 4 terabytes of main memory because the database interaction was so inefficient. They actually had to have it. It was still slow, you know. It was still slow, like from 0.5 terabytes to 1 terabyte to 2 to 4. It was still slow because of these inefficient access patterns. So increasing hardware, it is not a solution. Also, multiple CPUs, not a solution because it's consecutive. You cannot parallelize one session. If you have like 800 queries in one session, whatever, how many CPUs you have, it does not help. So hardware actually does not help. And then the other thing is, okay, we have Amazon, we have stuff in the cloud, so we can actually get like as much hardware as we want, just, you know, pay it, it will be delivered. So with Amazon, things are even worse. Because in Amazon, we have IOPS limits. Whoever lived in Amazon, they know what I'm talking about. Amazon never tells that they have these limits. They have these quotes, then they have these quotes, and then you start doing things, and then things start to be slow because they cannot provide this level of IOPS. So that's one, like if you ever use PGBudget, you know where it comes from. So that is the statistics from one application which was on Amazon, and they use ORM. And they were telling me, I thought, you do inserts row by row. I said, no, we know how we do insert. We have this one gigantic insert. That's what we have. So what we have here, we had 107 million inserts within an hour and a half. They were all super fast. So like average execution time was under a millisecond. So when you see 0, 0, that's like actually under a millisecond. PGBudget does not show more. Total execution time was 17 hours. So that's that's where slowness is coming from. And that was on Amazon, and they were like going like super slow. So that was like absolutely not good. Here comes NORM, and the goal of NORM is to reduce this number of round trips. So yes, we can talk about impedance mismatch because actually we are fighting impedance mismatch. But if we are talking about practical terms, we are doing this like reducing the number of round trips. So the word norm came up like I think about 3 years ago. So norm means no ORM. So norm, our new norm. Okay, and like in a nutshell, what we suggested that we have the transfer model. So we're not trying to map application to database. We're not trying to map database to application. We are creating transfer model, and then both application objects and database objects are mapped into the same model. And when we transfer data to and from database, we do it in bulk in large, complex, nested objects. So that's kind of like the gist of what we are doing differently. Because JDBC does not know anything about complex structures, what we have to do, we have to transfer this JSON model into a set of text lines, and then JDBC just transfers this array of text to array of text. But both on the database side and on the application side, we make JSON out of what we send and received. So in reality, that is JSON. And application developers, applications like contracts. So that's what we actually are doing. We are providing a contract. So we promise we will send JSON of specific structure. Application knows they receive it. So that is our contract, and that is like described by this JSON. So if we have database schema, like super easy, each application has it. We have user account. User account have first, last name, date of birth. Each user has like maybe several emails, primary, secondary, whatever, and they may have several phones, again, mobile, landline, whatever. And we have email priority and phone type. So like, it's easy because each application has user account. So what will be the transfer object? It will be just JSON. So we take this data and we present this as JSON with embedded elements. So you can see that we have like account, and we have username, last name, first name, date of birth. Then we have array of phones, and each phone is JSON, and we have array of emails, and that is it. So that was enough. So when I started doing it 7 years ago at Brave and Holdings, we just, it's easy to say we established. That was actually, it did not work as you think it should work, like lots of tries and errors. But at the end, it was beautiful because we start new development. That's our contract. Application developers do their side. I'm doing my side, like, and yeah, everybody happy. So how I'm doing it on Postgres side? Postgres, fortunately, can create user-defined types, and user-defined types can be nested. So basically, that is kind of how this result set looks like. So we have types for phones, for emails, for account, and when we select, we transform our result into the set of records of this type, not to JSON. So JSON is the last step. Here, most importantly, we transform them to user-defined type. And like, why not JSON? So at this moment, people asking two questions. First of all, hey, it's been a long time since we have JSON and Postgres. And by the way, we created it for application developers' convenience because they love JSON. So why we are not storing JSONs? So first of all, JSON is a hierarchy, so right? Because it's like starts from account and da. So when we store JSON, we store single hierarchy. I'm always saying when I hear yet another MongoDB, I was born and raised before relational databases. I started with hierarchical, and believe it or not, I remember exactly why we did not like hierarchical models, because it was single hierarchy. It's easy to query from top to bottom. It's hell to query across the hierarchy. So there's a reason. So we do not want to go back and store single hierarchy. We want to build as many hierarchies as we need. And the other one, why not returning JSON? That's actually also a popular question. We started from returning JSON. So why we don't want? JSON has no type. JSON is JSON. And we want to make sure we follow the contract. So when we return the specific type, we provide this strong typing dependency. So we are actually making sure that we return always what is expected. And while we are returning, we're converting it to JSON on the fly. It is better than building JSON step by step, because if you build step by step, it's super slow. Why it's super slow? Because each time you add, Postgres will validate that what you have is still JSON. When you give Postgres this whole complex type and say convert it to JSON, it's like one scroll through, and that is fast. Okay, so that's why we did this, and everything was actually super good. I am not even going, because it's like kind of in the interest of time saving, because it's in GitHub, you can see it. So what we did here, we created the user-defined, let me just start scrolling through this. So we created user-defined types. That's an example. And then we did this user-defined types, and then we created, for each of these user-defined types, we could create functions, and there were functions which would create objects, which would search for objects, which would update. So yeah, everything was pretty good, okay? And yeah, that had been like for a while. And yeah, so any problem with this? Actually, you know, in my company, application developers were super happy. When I tried to go to the conference, look what a cool thing we did. There are many problems with this. So not everybody happy, and people had problems. So there are two problems. First was we need database developer. And you know what? You might laugh, but that is serious for small startups. Like, nobody wants to have database developer as a separate entity. We want full stack software developers, like, because everybody knows how to do SQL, because SQL is a language which has only one operator, select, so easy. Everybody knows how to write select, how to spell select. So why you need database developer? So that's huge. So basically it was there. We need to have a healthy on each project. And when you use ORM, you do not need database developer. You can just use it and don't care what happened. So that was like one big problem. The other big problem was about this contract. So again, when I'm sitting in this room and my Java developers sit here, it's all easy. But like, to be honest, that is this JSON, that was a period of this JSON thing here. That's not a contract, right? Because it's like, okay, we want JSON of this kind. So we never formally specified how this contract would look like. So that was the other problem. So everybody, literally for several years, everybody looked at this and said, it's so cool, but no. That's cool, but we're not doing this. So then I just kind of became upset with this, and we need to formalize it. We need to make a framework, because honestly, it's like worse than any ORM, we could formalize it. So we focused on three things. We focused on formalizing the contract and automatic generation of functions. So automated hatching now. You do not need to have me on each project. We can generate search functions, and we can generate these update functions. And okay, so that is our newest GitHub. So NORM is our original, and I kind of like did not have a heart to drop it because it's everywhere on the internet, NORM GitHub, but there is like subdirectory, which is NORM-gen, which is generated NORM. So you can go there, and all the examples which I will be showing, they are there. So you can create these schemas, you can download this framework, you can install it on your local Postgres, you can run all the examples I will be showing. Like everything is there, like all of the scripts. So that's why I will be kind of fast. I'll just show how cool it is. First of all, how we formalize the contract. That was actually the biggest thing. And again, that is there. We use JSON schema to describe the contract. And like 1 second, I will show, I know that's like unreadable. I will show like bits and pieces. I just wanted to show how the whole thing looks like. So it's JSON schema, like Google JSON schema definition, everything according to the rules. So specifically, we have, okay, so that's our title, account hierarchy, the description, type array, because we can return multiple accounts, and each item is account, and then you can go to the definition. Then there are special attributes, DB mapping. So the beauty of this story is, first of all, if everything is named the same way and types are the same, you do not need to say anything by default. Second beauty is application developer can start this, okay, that's what we want. Database developer can come and fill in the blanks, how exactly we are going to map it. So here we have, okay, so definition of account is object, database mapping table account, that is the primary key, record type account record, properties, so date of birth, here same, Java does not have date, so it's type string format date, and we have DB mapping to the type date. Then emails are array. Each email definition is in email. Phones are also arrays, and each phone is defined here. So here we have email type. It's like table email, foreign key, primary key, and alias. That is kind of extra thing because remember we have email priority, so we need to lookup table. So we are also mapping lookup table so that we can display email priority, not just email priority ID. And same goes with emails. So there are actually 3 different hierarchies examples in this GitHub. So I think 2 are kind of pretty complex. This one is the simplest one, but I think that we covered pretty much all scenarios in terms of what is by default, which is not by default, what you can do. So then this whole framework consists of lots of metadata tables. So if you run load all, it will create norm gen schema locally, and it will create several tables which will store the results of this parsed JSON. And that's a separate function, which is contract analyzer. And it's all combined in one script, TS all, so it's transfer schema all. So everything populates schema definition, object definitions, keys definition. Again, I won't be showing these examples because anybody can like click, execute, you will have everything. So after everything is done, we pretty much can so like again that is a part of this GitHub. So I do not like running live demos because everything happens during live demos. So all the demos we just saw it multiple times. So everything here is pre-recorded, and again you can run all these demos by yourself. So here we pass this JSON object to the, just want to scroll it faster. So we can pass this object to function ts all, and it will execute, and it will create all this. Okay. So I just do not want even to spend time on demoing it. But okay. So next, okay, what is next? So after we are done with this, then we generating functions. So again, tables were already there. Contract was just provided, and we analyzed it, and we store all meta information about all of these objects. So now, that's important part. We are generating functions. So no human there. You do not need to write them. You can modify them after you generate it. And if you decide you need something else, or it's like not optimal, you can go back and modify. But I kind of guarantee that, yeah, I mean, kind of, because you can never be shown anything 100%, but I pretty sure that it's like the most performant for majority of cases what we generate. So we generate search by ID. So search by ID is important because whatever is the result, we created new object, you want to be able to display object by ID. Then search, generic search by arbitrary set of criteria, and most important, norm to DB. So it's like a general converter of data from application to database. So all inserts, update, deletes are performed by one function. So let me see whether I actually, okay, so let's actually, it's fine. I think I have time to actually show what's going on here. So what we're doing here, we are generating this select, which I showed before. So this select is generated based on the type description. Okay, so I did not write it, just not so nice, but it's the same select. So what we're doing then we run generate select by ID for this hierarchy. So we pass the name of the hierarchy, and we generate the function which will select by ID. So after we ran it, so true, it returned. Now we can execute this function. So now by executing account search by ID. This function did not exist before, we just generated it. And yeah, we actually receive results, and in order to display it nicer, we will do it using array transport. So that's the result. So we passed 2 IDs, and we received 2 like JSONs. Okay. Okay. And then what we're doing next? Okay. All right. So then what else we are doing? Then we are generating generic search. That's actually very interesting because, like, I guarantee I will generate search by any attributes, any combination of the attributes which can happen here. So now we generated it, and now we execute it. So we pass complex search criteria. I will show it in a little bit more details in a second, okay? So we execute, and as a result, we received like 1 attribute. So now let me actually do this array transport, because otherwise it's non-readable. Okay? So okay, we now got this nice JSON. Okay. All right, and okay, are we done here? Yes, we are done here. So let me keep going. Okay. So So that is the search criteria, and that's what we generate. So people actually kind of yell at me when I'm saying Mongo is not a database, but I mean, it's not a relational database, which I kind of doubt it is a database. But now if you look closely at the syntax, which we are duplicating, so our search criteria is built on pretty much MongoDB syntax. So you pass something which you do not need to know it's Postgres behind it. So you pass what is on the right, and our function generates this search condition from this MongoDB syntax. And it generates nice, beautiful relational search using B-tree indices. Okay? So, and then, yeah, application developers still do not need to know SQL. No? And the last part here would be generating inserts, updates, deletes. So that is actually probably the most difficult part. We worked on it for a very long time. And the function here is we generate norm to DB. So we generate it, and after we generated it, we can use it for inserts, updates, and updating of embedded objects, and on deletes. So here in the first example, we insert new object. In the second example, we update some attributes of the main object. Then on the next one, we update something in the embedded object, and in the last one, we delete embedded object. So we can delete a phone from like one of the accounts, a specific phone, or we can update one of the emails on the specific account. So again, there is a demo for this one. I kind of like do not want to spend lots of time on it. Again, you can do it, you can run it, you can go to GitHub, but yeah, all of these functions work. So I think that, again, as I said, this is all, like, we can probably skip. And so like summary. So first of all, I heard a couple of times, you created another ORM. You were so anti-ORM, and you created another ORM. So why it is different from ORM? So once again, because I know it was a long time since I started talking. It's what Joselka was saying, thinking sets. So if it is ORM, it's like right ORM, because it allows us to manipulate complex objects. We are not mapping like attribute by attribute. We map hierarchy to the database created hierarchy. So mapping complex objects. And we do not do it one by one. We can do this whole bulk select, we can do bulk update, bulk insert, etc. And we can do the database work inside database, okay? So other programming languages. Details may vary, as I said, but mostly, so that was mostly developed for Java, but actually that works for everything. Active record for Ruby on Rails, that was like a little bit more complicated because Ruby thinks they know how things should be. But again, I had successful implementation on Ruby. Again, storing JSON versus building JSON, I already mentioned. We do not want to store JSON because we want to have all power of relational schema, all power of B3 indices, and all power of relational search. We want to do multiple hierarchies. So that is pretty much all we had. Actually, you know what? I forgot to include one slide, but that's okay. I think because I kind of try to cover at least what's new, because I know half of this what some of you already saw. But that is actually pretty much new because this automation, it was recently finished. It was finished like less than a month ago. So my big ask, please go to GitHub. I want to see my stats, booming as everybody. Please try it. Please try it. Please use it. Please tell me what does not work. I have several open source projects, and I use them. For example, I used PGBitemporal for 7 years in production, and I'm like, okay, I fixed all the bugs. Then there were 2 small startups who started to use PGBitemporal, and they started sending me issues. Like, oh my gosh, I never thought that would be an issue. So I fixed lots of stuff in PGBitemporal. So please go try, tell me what is wrong. Send me all your grievances. Try to convince your application developers that there's something worth trying. And and in general, that is open source. It's up for grab. Again, I've been in EDB for 9 months, so there was no desire to, make it proprietary software. So it's still free. Okay, still mine. All right, thank you.
Thank you. Any questions?
Yeah, I've got 2 questions, if that's okay. First, I maybe just missed this. Are the table definitions also being generated from the types that get submitted?
No.
Okay.
No, we know what is the work of database. Okay. No, so that's why I'm saying. So table definitions are separate because that's what we want to have control on. So I'm saying it works without database developers, but in reality, what? If it will all work without database developers, it will be like what Ilya was showing us yesterday, one gigantic key value table. Now, so here it's just very easy to separate the duties. So database is database, and database developer like DBA can actually do the actual mapping.
Okay, and then my second question, on the GitHub, are there specific things that you're looking to improve? Is there an issues list?
There are no issues list yet, but I hope it will be there. So honestly, when I did not do it in production because I did not work for any real company for a while. So we tried it on small examples, and small examples sometimes you can miss it, you missed important condition, join condition, and then you go and try to do one bigger. Oops, it takes forever. Shoot. I do not know what will happen if people will start trying it, but I'm sure something will happen. I'm 100% sure that we overlooked something and we did not account for some interesting joins or everything. So I'm waiting to see what we did wrong, because we definitely did something wrong.
Got it. Thanks.
So my question was kind of related to what you were touching upon here at the end there about what you tested it on. So I wonder what kind of load testing, what kind of data sets did you test it on initially to kind of get them?
Yes. So my approach in general, so norm without norm gen, that is tested for very long time in real life, and that was this startup which I built from very beginning to multi-million dollar revenue. The Braviant, yeah, they're like, when I left, they had like 60 million revenue already. Now they're like over 100, I think. And they were like huge data sets because also I implemented it together with PG bitemporal. So that was like completely bitemporalized tables. So it's like, 5, 6, 800 million rows in the table, and it all worked. So the only problem, the only thing I did not test there, everything was like handwritten. So though we knew all these patterns, how these packages should look, how the selects were looking, but it was like me and my like very small group of database developers. So I know that approach itself works and extremely stable. So the thing which like I think is important to understand, yes, when the data grows, like execution time some point grows, but the question is whether it's growing linearly or logarithmically. Because if the query is built correctly, and that's what we can do with these functions. So it's not like, each time you query something 10 times larger, you have like 10 times more execution time. It was pretty much stable, for all the time I was there. So that was on the absolutely real data set. So the thing which was not tested is like how well my generated functions will work in like real life. And I am absolutely sure that in many real life cases, they shouldn't need be tuned somehow, but at least you have this bulk of code. There's lots of code, And if you look at norm without norm gen, you will see like handwritten packages. You will see that like huge, there are lots of code. And at least you don't need to do that. You can like go and see what exactly does not work as expected. And then you can modify these selects inside, but that will be minor and would not actually require anything from the application developer.